Okay, so we have done using we have basically isolated it into a function. Now we will allocate it dynamically. So let me copy it into the next serial number, and now we will allocate it dynamically. Okay, calculate sum will remain as it is, it will not modify. All we are saying is that don't take this statically, don't let it not come from the stack, do malloc, let it come from the heap. So we will comment line number 31. So let me so we will comment it, and instead of that we will just declare pointer to int. Pointer to int and array of int are highly same, and we will allocate memory of the array. So how do I allocate memory? Assume somehow I know the length. For simplicity I will just hard code the length initially. I will change it in a moment. Okay, or maybe what I'll do is I will print to the user enter n. So I will ask the user, I will say enter n. Okay, and I will ask the user what is the required number. So I will say %d ampersand n. Variables are typically written in lowercase. Okay, and I now have the length of the array n. User has told it. Okay, and now I want to allocate memory. How much memory do I want to allocate? Let me just think in that picture. So basically I want to create this thing. I want to create int n times. So how much will be the total space? N integers. It will be n into size of int, because I have n values one after the other contiguous. So I can happily write that ptr is equal to memory. How much memory? Malloc, how many bytes to allocate? Size of int into n. That much bytes I want. Okay, and from a convention perspective I will typecast it explicitly to int star. So now this ptr you can consider as a dynamically allocated array. You can for all practical purposes use ptr as a array. You can do ptr 5, you can do star ptr, which would mean the 0th integer, and so on. So ptr is practically the array. Okay, now I want to take n numbers from user. So I will, okay, ideally I will do a check also. If ptr is null, then then maybe I print something and I exit. For now I will just exit. Ideally I should print a error message, but I am just being lazy. I will just exit, and now I will in a loop take values. I will say I equal to 0. How many values I want to take? N. I less than n, I plus plus, and here I want to fill. What I will say to the user is I should print something to the user. I will simply say enter. How many integers should he enter? So whatever that number is, I will say please enter that many integers. So maybe I will remind him that he has entered n. So I will say enter n integers. Okay, and then I will scanf those many integers. I will say read the ith value. Read the ith value. How do I read one integer? %d and address of that integer. What is the ith integer? It is ptr I. Okay, ptr I, because ptr is a array itself. Ptr is a dynamically allocated array. Size of ptr is 8 bytes only in my platform, size of address, but it's a dynamically allocated array. I can use the array style syntax. Okay, so this should be okay. And in fact, as I mentioned a bit earlier, you can use this notation also, ptr plus I. Instead of line number 47, you can use line number 48 also, but we'll come to that. For now, let's try to make it work with line number 47, which is most intuitive. We are saying the ith integer address of that, read there. Okay, so pictorially we are saying the loop goes like this: address of 0th element, address of 1th element, and so on. And it is reading n integers. It has read all the integers. Now I can happily pass ptr. It's compatible. It's now literally it's compatible. Pointer to int and array of int compatible. I can pass it. Okay. The only little thing I have to add is I need to free it, because whatever resource we take, we need to release them. So we should free it. So let's see. Unless I have made some error, it should work. So let's see whether it compiles well. So I will remember the pwd. I mean, where am I? I will go there. So from inside VA you can execute commands. Let me reach there. I'm here. Okay. Now I will compile. I will say gcc minus wall sum4.c, and I made some errors. I forgot the semicolon here. Okay. What else? Anything else? I is undeclared, length is undeclared. Okay, so I will declare them. Length, I think length I should change to, so I need not print this length, by the way. I is undeclared, I can add it. Let's see if more errors have. So let's see. Wait, len is undeclared, so somewhere this length. Okay, I should change this length to n. Okay, that should be good. Let's see. And it compiles well without any warning. That's a healthy thing. And if I say enter n, and I will say 5, now it is saying enter 5 integers. I can enter them one after the other. So 1 2 3 4 5, and the sum is 15, which is n into n plus 1 by 2. 15 is the correct. So this is correct. So basically the short principle is dynamically allocated arrays are that simple. You take one element, you multiply by how many elements, you get that much memory, and a pointer to int you can consider as a array of integer if you allocate n integers worth of space. And then of course, as we discussed, these principles we can remember. Array versus pointer, syntactically they are absolutely same. Array, the only thing is it's bound to the 0th element. It doesn't change. You cannot say ARR equal to something else. Size of pointer versus size of array is different. Obviously, size of array is the entire size, one element into number of elements. Size of PTR is just the address. And when we pass an array to a function, it degenerates, decays to a pointer. It becomes literally the pointer. Even the size of will be size of a pointer. So these little things we have seen, and I think this is dynamic allocated arrays are just that simple, nothing much.